Alright, so here we are with the 8-5 sampling distributions notes. So our objectives are to estimate population means and proportions and develop a margin of error from simulations involving random sampling. Lots of words, but anyway. And then we're going to analyze surveys, experiments, and observational studies to judge the validity of your conclusion. So you've got lots of vocabulary that we are going to be defining today, so those will all come up. Alright, in fact, right now. So our first one here is simple random samples. So simple random samples, if you kind of think of it as this being your population here, very randomly from each column and row here, the members are chosen using a method that gives everyone an equally likely chance of being selected. And there are things like random number generators and things like that that can help with simple random samples. Usually simple random sample, if you can do it, is the best one because it doesn't, discriminate between, age or anything like that, and so or where someone is. It's just the entire population gets some random sample. Then we have a systematic sample, and systematic samples have members that are chosen using a pattern, so just selecting every other person, which we tend to fall into when we think that we're doing a simple random sample, but what happens is you get a systematic sample because you're actually saying, oh, I'll do every fifth kid that comes in the building or whatever it is, so survey them. Then we have a stratified sample, and that's an interesting one, but basically the population is first divided into groups depending on what they want. For instance, at school it might be like your grade that you're into, and then we want representation from each grade, whatever it is. And then from those groups, members are randomly chosen. So that's your stratified sample. Then we have our cluster sample, and a cluster sample is the population is divided into groups, and a sample of the groups is randomly chosen. So you're already in groups, and then within that we just pick one of the groups to represent. So what I was using earlier, that example wouldn't be helpful in this one. So if I only surveyed all the seniors, that would not necessarily be representative of the entire school. But sometimes cluster samples do work. So perhaps choosing everyone that came into a store on Monday is probably the same as everyone that came in on Tuesday or Thursday. So that one might work. Again, just depends on the scenario. Then we have our convenience sample, and those are usually, again, more convenient, but not necessarily the best selection. But members are chosen because they are easily accessible. So, for instance, we might give a survey via email, but of course not everyone checks their email as much, and so that might be just a convenience sample because I'd rather not call people. Then we have the self-selected sample, which is not always the best because, as we've seen in comments online and things like that, usually you only get things from the people that had the best service or the worst service. And so volunteering to participate is usually only going to get those types of categories. However, depending on what you're trying to survey, it might be helpful. So we've got our classifying a sample here. So the campaign staff for an event for a state politician wants to know how voters in the state feel about a number of issues, and we're going to classify each sample that they are using to get this information. So the first one is they call every 50th person on a list of registered voters in the state. And so that one, as we learned in our definitions before, is going to be a systematic sample. Because again, you've got that every 50th person, you've got that system going. The next one, they randomly select 100 voters from each county, and so this is the one where we're saying that they're broken into a group, and then from that group they are selected. So this is a stratified sample. The next one is they ask every person who comes to the next campaign rally to fill out the survey, and this one is definitely just a convenience sample. They're already at the event, and so we'll go ahead and ask them. All right. Then we have a probability sample. It's a sample where every member of the population being sampled has a non-zero probability of being selected, meaning every person could potentially be selected and asked what's going on. Simple random samples, stratified samples, and cluster samples are all examples of probability sampling. Again, where every member of the population has a non-zero, meaning they will potentially have the probability of being selected. Because if you have a 0 probability of being selected, that means you'll never be selected, so unfair. So, this next one here, a community organization has 56 teenage members, 103 adult members, and 31 senior members, and the council wants to survey the members and classify each sampling method, which is more accurate and which is least accurate, and explain. So, method A says that they are going to randomly select 60 people from the complete membership list, and so this is going to be a simple random sample. The next one says they're going to choose every 5th person who arrives at the community cleanup event, and so that is going to be a systematic sample, because again the system is every 5th person. And then the last one, randomly select 20 teenagers, 20 adults, and 20 seniors from the complete roster, and so that one's going to be that stratified example, because they're in the groups of those 3 categories of senior, teenager, and adult, and then you are within each group picking a select number of people. It turns out that method A is going to be the most accurate. Again, because we're doing that simple random sample, everyone is likely to be selected with no lenience towards anything. Method B is the least accurate because the members who do not attend the cleanup have no chance of being included. So this is least, again, because you'd have to be at the event. And then method C has an equal number of people from each group, but since the total numbers are so much different, I mean, if you're doing 20 of the 31 seniors, you literally have represented 2/3 of them, or 66%, versus the adult members, you've literally only done like 20 out of 103, so 20% of them. So 66% versus 20% isn't really very equal. So we've got inequitable percentages that are surveyed. I mean, it looks like you're being even because, oh, sorry, that's the method C. I need to move these. Okay, anyway. So that's the idea. And again, some of them could actually be very helpful. Like maybe the seniors are the ones that are more likely to come out and volunteer, so we should survey them the most, or whatever it is. So it kind of just depends on the scenario, of course. So then the next piece here is your margin of error. And of a random sample, the margin of error defines an interval centered on the sample percent in which the population percent is most likely to lie. So apparently this is kind of your center of the response, and then the margin of error needs to add 3%, but then also subtract 3% of the voters in the population when we're talking about this case. So again, the margin of error is plus or minus 3%, meaning that the percent of voters in the population who plan to vote for Smith is likely to lie within 3 percentage points of 58. And so that means that we could be between 55% to 61% likely to vote for Smith. And again, that's just because usually they're doing exit polls or whatever it happens to be, and because of the fact that these are convenient, the idea is that they won't necessarily be to the point exactly accurate. So, this will happen a lot when we're talking about elections. You'll see it on the news, and they'll say, oh, with a margin of error of this much, and so if they're trying to call a race or whatever, or whoever won, they might not be able to because the numbers are too close for that error to work. So, for instance, an example here, a city is about to hold an election according to a survey of a random sample of city voters. 42% of the voters plan to vote for Poe. Apparently that's who that person is. And 58% of the voters plan to vote for Nigel. I don't know. Anyway, that person. The survey's margin of error is 7%. Okay, so that means that for both of them, for Poe, for instance, you've got 42%, and you're going to add 7%, but you're also going to subtract 7%. And so the new range of values that could be voting for Poe is going to be 35% to 49%. The other candidate is going to have 58% where it's centered, but then they could add 7% to that, or they could potentially be subtracting 7%. And so their margin is actually 51% to 65%. And so the interesting part about that is that the highest that is for this candidate versus the lowest for this candidate never meet. And so because the ranges do not overlap, you can call the race for, we'll just call them Nigel, since I don't know who they are and they can't tell me. All right. Sweet. So that's the idea of, again, margin of errors, which we've kind of explored a little bit in Chapter 8, but then also kind of this distinguishing what type of distributions or collections of data we have.